Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM. This is a problem from the old study note for exam FM, number 53, and the latest study note, problem number 53, is on a related topic but different. But nevertheless, it's an interesting problem. Joe must pay liabilities of $1,000 due 6 months from now and another $1,000 due 1 year from now. There are two available investments: a 6-month bond with face amount of $1,000 and 8% nominal annual coupon rate convertible semi-annually, and the 6% nominal annual yield convertible semi-annually, and a 1-year bond with face amount of $1,000, a 5% nominal annual coupon rate convertible semi-annually, and a 7% annual yield convertible semi-annually. So 7% nominal annual yield convertible semi-annually. What is the annual effective yield rate for investment in the bonds required to exactly, absolutely match the liabilities? And here's the solution. We will find the spot rates for half a year and a year and use them to discount the liabilities cash flows to find the price of the bonds that would match the cash flows. So the spot rate for half a year, semi-annual spot rate, is 3%, as given. The semi-annual spot rate for the full year, S2, and I write 2 because it's 2 half years. We look at semi-annual rate, so it's rate over half a year, but over 2 years, spot rate. So the same rate over the first half a year and the second half a year that produces the result we want. Has to be derived from the pricing of the 1-year bond, which is 25 over 1.035 plus 1025 over 1.035 squared, because 3.5 is the yield of that bond. And that's equal to 25 over 1.03, that's the spot rate pricing of a payment of 25, plus 1025 divided by 1 plus S2 squared, which is the spot rate pricing of the payment of 1025 at the end of the year, which is 2 half years. And we solve it for S2, because S2 is the only unknown in this equation, and obtain about 3.506342%. So the cost of purchasing the bonds required to exactly match the liabilities is the same as the present value of liabilities cash flows at the current market rates. Therefore, the cost of the bonds required to match the liabilities is 1,000 over 1.03 plus 1,000 over 1.0350634 squared, and that's about 1904.27. And what we have here is that payment, an investment of 1,904.27 now, produces cash flows of 1,000 in 6 months and 1,000 in a year. And you may wonder, what are the bonds? Well, it doesn't really matter. We actually solved it in one of the previous problems, but it doesn't matter because whatever the bond portfolio is, it will cost this much, 1904.27, and will make a payment of 1,000 in 6 months and 1,000 in a year. And the yield rate must be a solution of the equation that 1904.27 accumulated at the interest rate I over a year, minus a payment of 1,000 in half a year, and that payment accumulated to the end of the year is 1,000 times 1 plus I to the 1/2, and minus a payment of 1,000 at the end of the year. This all has to be 0 because this 1904.27 paid at time 0 produces these two cash flows, and I is here the effective interest rate. So this can now be solved by treating x equal to 1 plus I to the 1/2 as the unknown. This becomes a quadratic equation. You can use the quadratic formula, and when you do that, you get I to be approximately 6.777201%. But we actually can also use simple interest approximation. The gain that we have is 1,000 plus 1,000, so 2,000 is the total payment, and the cost is 1904.27, so the difference of the two is the gain, the interest on the amount invested, and that's 95.73. And 1904.27 is in the account for a full year, so you can think about this as 1904.27 times 1. And then 1,000 is taken out in the middle of the year, and so that's subtract 1/2 times 1,000. And this becomes 95.73 over 1404.27. It's approximately 6.817065%. Amazingly, that is the same answer choice, so we're lucky it's answer D. Please remember this is copyrighted material. The problem itself belongs to a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.